Welcome back everyone. So today we are going to do acid catalyzed dehydration of 4-methylcyclohexanol. So the first thing to do is to weigh 4 ml of this solution in 10 ml graduated cylinder. So I'm going to tear this graduated cylinder. And then weigh it at 4 ml. It's about 4 ml. So the weight is 3.6814 grams. So here you can see better, right? So this is the weight of 4-methylcyclohexanol. So next we transfer this 4-methylcyclohexanol solution into 10 ml of round bottom flask. So the reaction setup is we're using simple distillation setup, right? So you need 10 ml of round bottom flask, and it has a stir bar at the bottom, and then you add 1 ml of phosphoric acid. I have sulfuric acid, so I'm going to add 16 drops of this. Drops. Then I connect this round bottom flask to simple distillation setup, right? So I have setup and bring down. Okay. Make sure it's in contact, it's good. And turn on the water. Where's the water? Right here. So you have a condenser here, water condenser. So water comes in from the bottom and out from the top, right? And I also have a receiving flask. It's about 4 ml conical valve connected to the simple distillation setup, and you turn this hot plate on. There's the power supply. So I have the hot plate setting at 160, and you notice the solution mixture is turning brown. So the charring of the reaction mixture from sulfuric acid, right? So I have to keep this reaction stirring for 45 minutes. So let's just wait. So it has been 45 minutes, and you notice I have collected some distillate from the reaction, so that's good. And the temperature is between 90 to 100. Yeah, that's the correct temperature that the distillate should come out. That's good. So I'm going to open up this reaction vessels. So it's still very brown. That's good. It's charring. It's supposed to turn black. So that's good. I insulate it with aluminum foil to keep the round bottle flask warm. Okay. And I'll let this continue until I get 3 mils. It hasn't reached to 3 mils yet, so I'm gonna let this continue another 10 minutes. So I have collected about 2.5 ml of distillate, right? And I'm gonna dry out this solution and isolate the product. So add saturated sodium fluoride solution, about 2 ml. It says to use centrifuge tube, but I'm gonna do it directly in this valve, conical valve. I think that will fit, about 2 to 3 ml. So that's good. And shake it and vent it, right? So I'm doing the extraction step directly in a conical valve. So that's good. Notice there are 2 layers. It's a bit difficult to see, right? You see the 2 layers? So the bottom layer is aqueous and the top layer is again organic, right? By now you should know, right? So I will pipette out the bottom layer, right? Bottom layer. Can you see? Oops. This is good. So now we have organic layer transfer into a test tube, right? A clean, dry test tube. So we have organic layer. Use a new transfer pipette. Transfer. Okay, and add anhydrous sodium sulfate, right? That's again is a drying agent. So just 1 spatula full. This is good enough. Oops. Yeah. So and I'm gonna let this sit for a good 10 minutes to remove all the water, right? Water, any traces of water in 4-methylcyclohexene. Okay. So I transferred the dried 4-methylcyclohexene solution into a new conical valve, and I need to get the weight of this solution, right? So I teared out the weight of the glass and the cap of this conical valve, so I'm going to weigh only the solution. So the weight is 1.3820 gram. Okay, so it's 1.3820 gram. That's the weight of 4-methylcyclohexene. So next we are doing unsaturation test. So we're testing for the presence of carbon-carbon double bond in 4-methylcyclohexene, right? So I have 4 test tubes here, and in the first test tube we have 4-methylcyclohexanol, right? So this is a negative control, and also in the third test tube we have 4-methylcyclohexanol. Okay, so 3 to 4 drops of 4-methylcyclohexanol, and in the second and the fourth test tube we have 4-methylcyclohexene, right? The one that we synthesized. So I'm gonna put in bromine solution in the first test tube, the 2 test tube, and then followed by potassium permanganate solution in the third and fourth test tubes. Okay. So 2% bromine solution is in dichloromethane, right? So I'm going to add a few drops to each test tube, and so bromine solution is red color, right? Just going to add just a few drops. So you can observe the color, and it's remaining red in a 4-methylcyclohexanol, right? And when I shake it, it's still orange, right? Okay. And into the second test tube, that's where 4-methylcyclohexene is, right? 2-3 drop of bromine solution. Right? So the bromine solution mixing with 4-methylcyclohexene is colorless, right? So the color is discharged. So if you compare the first and the second test tube, the first one is orange, and the second test tube is clear solution, right? So in the third and fourth test tube I will add 1% potassium permanganate, just a few drops. Okay. Oops, that's a lot actually. And I will add 1,2-dimethoxyethane. Why do we need to add this solution into potassium permanganate? Just add a few drops. And shake it. So it's more homogeneous, right? And it's purplish color. Okay. Fourth test tube. 1, 2, 3. Mixing it. Right, I'm going to let this one sit so you can observe the solution better. Okay, so in the third test tube we have 4-methylcyclohexanol with potassium permanganate, and in the fourth test tube is 4-methylcyclohexene with potassium permanganate. You notice it's a little bit brownish color, right? And you have a precipitate at the bottom. So let's compare the 2 test tubes. Now when you compare it, it's more obvious, right? So oops, my hands are shaking again. Alright, so on the left I think it's purplish, and on the right the test tube is more brownish, with the precipitate at the bottom. So what does it mean? Okay, so this is good, right? Okay. So this concludes the experiment on 4-methylcyclohexene, and I hope all of you come back in the fall, and I wish you good health. Bye bye.